Hello, welcome to this presentation where we're looking at classification of numbers. And in this presentation, we want to look at first, we deal with even numbers and the odd numbers. All right. Now, how best do we understand this? Let's look at, suppose we have a set. Okay. A set with the following numbers. 0, 1, 2, 3. Maybe I can even do this. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, suppose we do them, since we are saying it's a set, we do them like this. All right. Now, when you look at this set, we can try to identify some properties. All right. For example, let's identify the numbers which are divisible by 2 exactly, meaning that we don't need to have remainders. Okay? So what is it that you're able to see? From this set, we can pick, this implies that we can pick 0 because 2 into 0 will be 0. All right? What else? We can pick 2. What else? We can pick 4. Next, we are able to pick, I think, 6. Next, we can pick 8. Next, we can pick 10. Next, we can pick, we have 12, yes, 12. Next, can pick 14. All right? Then we can also try to pick the numbers where when we divide by 2, we'll be able to get a remainder. From here, we can pick the following. From here, we can pick the following. We can pick 1. All this. 1, 3. So we'll pick on 1, 3. What else? We have 5 here. Then we have 7 here. Then we have 9. Then we have 11. Then we also have 18. So these numbers that can be divided by 2 exactly are even numbers, are called even numbers. Whereas these that cannot be divided by 2 exactly are referred to as odd numbers. That's it. That's the difference. All right? So we are saying by definition, even numbers are numbers that are divisible by 2. Okay? That's what we mean. Maybe we emphasize, say exactly. That is, without giving a remainder. What does it mean? For this one, we can say these are numbers that are not exactly divisible by 2. Okay, that's what we mean. So you can see that we have got 1, 3, 5, 7, so on and so forth as our odd numbers. Then 0, 2, 4, 6, 8, 10, 12, and 14 as our even numbers from this set. But now, these even numbers can also be given in terms of positive and negative numbers. All right. For example, if I look at negative 4, is an even number because they're able to divide by 2, and you'll be able to get negative 2 exactly. Right? It can also be given in terms of negative numbers. All right. If you look at these odd numbers, you can have negative 3 is an odd number, right? Though it's negative. Because negative 3 divided by 2, you get negative 1.5. All right? There will be a remainder of 1, remainder 1. So this one is also an odd number. So when you talk about odd numbers where when you divide by 2, we'll be able to get a remainder or a decimal number in short. All right, a decimal number. For even when we divide by 2, we'll not get the remainder, we'll get an exact value, a whole number. All right. Maybe we can look at a question. Let's look at a question. Given that set A is equal to 1, 5, 6, 10 and 25. State 1, or maybe we say state or list we want. The even numbers. To odd numbers. All right. So we can even provide answers at the end here. So in this case, are we able to divide 1 by 2 exactly? No. How about 5? No. So this one is not even, this one is not even, this is even, this is even. So we'll have, I can even put in a set, 6 and 10. This one, no. So these are the only even numbers that we have here. All right? They're the only even number that we have. Then, for this one, what do we have? It means when you remove even numbers, whatever will remain will be odd. So we have 1. Well, if it's not odd, then it must be even. 1, 5, and 25. Those are our even numbers. All right. Okay. So that's what it is. Okay. That's what it is. So I hope you're able to define these things. You're able to really appreciate what they mean. Okay. We can look at another concept. Okay. From okay. From those two concepts, we can look at maybe a factor. Let's look at what a factor is. What is a factor? All right. Now, suppose we have, suppose we have 4. Suppose we have that number. Okay. Let's say list all the numbers which can divide into 4. By 4 mean exactly. All right. So, do we have such numbers? Yes, we do. All right. 1 can divide into that, and it will be 4. 2 can divide into that, and it is 2. Then we have 4. All right. That's it. Hey, wait. But we can still put some more. All right? We feel even negative numbers can divide. Therefore, we can have also -1, -2, and -4. What does this imply, therefore? The factors of 4 could be plus or minus 1, plus or minus 2, plus or minus 4. That's what we mean by factors. Okay, that's what we mean by factors. So, by definition now, a factor is a number which divides a number under consideration exactly. All right. So that is a factor. E.g., the factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Those are our factors. So if I give you two numbers, for example, A, find the factors of 8 and 12. Then B, find the HCF of 4 and 12. What would be our solution? Okay. What would be our solution? Okay, so it would be our solution. Okay. This is what we are going to get. So, solution. Number 1, we want the factors of 4 and 12. So what are the factors of 4 and 12? So the factors of 4 are plus or minus 1, plus or minus 2, plus or minus 4. All right? How about 12? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. These are the factors. Number 2, we want to find the HCF. HCF of 4 and 12. Now, you must identify a factor that is common to these factors here, and that number should be the highest. Here the highest is what? 4. Here the highest is 12. But realize that 12 is not a factor of this, but 4 is a factor of that. So 4 is a factor for both numbers. It is common. Therefore, the HCF, the highest common factor of these two is 4, plus actually and minus 4. That's it. Then we talk about multiples. Now, by definition, what is a multiple? A multiple is the result of multiplying the number under consideration by an integer. An integer could be negative, positive, or indeed 0. So what does it mean? If n is an integer, all right, then the multiples of maybe we say if n is just maybe a number, yeah, I think we just say a number, not necessarily an integer. Maybe we say is a number, yeah, is a number, all right? Then the multiples of n, okay, are n times k, where k is now an integer. E.g., find, list the multiples of 3. Okay. What is our solution? So we are going to say 3 by 0 if you want. So you get 3 as your first one. Maybe 3 times 1, you get it, 3. 3 times 2, you get it, 6, etc. All these are multiples, all right? All those are multiples of 3. Okay, we can write it nicely here. Okay, so we said 3 maybe by 0, we get it, 3. 3 by 1, we get it, we get 0, then 3. 3 by 2, we get it, 6. Or 3 by negative 1, we get negative 3. 3 by negative 2, we get negative 6. 3 by negative 3, we get negative 9. So therefore, you see that the multiples of 3 start from what? 0, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 12, up to infinity, both negative infinity and positive infinity. Okay. I hope you understand. So, in conclusion, we have looked at even numbers, odd numbers, factors, as well as multiples of a number. Okay, this is where we end for this presentation. Please look out for more videos on Mathematics 1, Form 1. Okay, please, you can subscribe to our channel, Kanban, PD, JM, then Chaomba Mbondo. You want to contact us, you can contact us 0978 56 58 76. We are providing lessons for Form 1s, grade 9s, 10s, 11, all the way up to 12. And our GCE lessons are starting on the 20th of this month. Please don't be left out. Don't be left out. Mark the date, 20th. You can contact us. It's only 500 kwacha per month per person. 500 kwacha per month per person. Mathematics only. Till next time, bye-bye and God bless.